All right, let's do an example of how to find the one variable statistics for a set of data. Over here on the right side of the screen, I have a set of data that are density measurements for the Earth that were collected in 1798. So in order to get the one variable statistics, I'd like to know the mean, the median, all that kind of stuff. I'm going to start off on the home screen of my calculator, and I'm going to go to a new document, and it's going to say, do you want to save the unsaved? No. Okay, don't save that. And I'm going to go to add list and spreadsheet. This is pretty much where we start anytime that we have a set of data. I know that these numbers represent density, so I'm going to come up here and I'm actually going to write the word density, type that word density up into there. You always want to label your data, even if you just put an X up there or something. You always want to say what it is. And then I'm going to go ahead and start entering these values. Now there are 29 values in this list, so it's going to take me a little bit to get them all entered, especially if I was typing this in on a handheld like you have. So one thing to note, even though my data is in these three piles, I'm going to enter this in one big long column. So all 29 numbers in one row. I'm here at 5.07. I'm going to pause the video and I'm going to enter in the rest of these values, and then I'll be right back. Okay, so I just entered this last number, 5.85. Notice I'm down here in cell 29. I know there's 29 numbers. That makes me happy. That makes me think maybe I got them all. So when you're done with that last number, you want to make sure you arrow or enter out so you're not actually sitting in that same cell as one of your numbers. It doesn't really matter where you are. And now we're going to run the one variable statistics. So I'm going to press menu and then number 4, statistics. Number 1, stat calculations, and number 1, one variable statistics. The first thing it says here is number of lists. We want that to be 1. And my X1 list, this is asking me what my variable is. So I want to click over in this arrow. Remember, you can use your little touch pad on the top of your calculator to get there. Or you can sort of arrow in there, and we want to pick that variable name that we chose, density. Notice that the density has a little apostrophe in front of it. That's important. If you were to take your keypad and just type in the word density, this wouldn't work. You actually do have to click in there and choose that variable. That little hash mark in front of it is the calculator recognizing it needs to pull that from the variable list. There's a couple other things in here. Frequency list, category list, include categories. We aren't dealing with anything fancy that has categories or more than one of one value. The other thing I noticed, it says first result column, and it says B. This will generally default. You don't really need to mess with this. It'll default to a place that's open for your calculator to put the data in. All right, so I've clicked that variable. I'm going to press OK. And I notice that it's done something up here, but I can't really see any numbers. And that's because I'm way down here on row 29. So instead, I'm going to work my way up. I'm going to arrow up. And sure enough, here come those data values. So these are the one variable statistics. So one thing I noticed, I've got this thing X with a little bar over it. That's called X bar. This is sigma, capital letter, Greek letter sigma X. That means the sum of the X values, the sum of X squared. SX, sigma, this is lowercase sigma X. N, min X, Q1, median X, Q3, max X, and then SSX. And notice you've got a little formula that's sitting beside there that you can see. So I have all these numbers that have been calculated. So I'm going to go back over to my document and I'm going to type these in. So X bar is 5.447, etc., sum of X, and let's go over there and talk about those. So I'm going to copy these over, and here are those values. Now, these are my, these are my delightful one variable statistics here. And so here's what I know about these numbers. So first off, this value here, this is X bar, and X bar tells you the mean of the data set, which means if we would take all 29 numbers and add them up and divide by 29, we would get 5.448. Sum of X and the sum of the X squared. Sum of X is literally what these would add up to before you divide it by 29. The sum of X squared is 5.50 squared, 5.61 squared, 4.88 squared, etc., all the way down, squaring each of the individual values and then adding them up. Both of those are used in several different statistical formulas. However, we'll very rarely use them in here if we're not substituting directly into a formula. So you can just, I kind of grade those out. You can kind of ignore those for right now. The other thing that's next is this SX and this sigma X. And again, this is the lowercase Greek letter sigma. Both of these are standard deviation. Standard deviation. There is a different formula for calculating sample standard deviation and population standard deviation. So you, as the statistician, have to know, did I enter in sample data or did I enter in population data? If you know that the data you entered was a sample, then the calculation of standard deviation for that sample would be the SX number, 0.221. If you know that this data represents the population values, all of the numbers in the population of interest, then your standard deviation would be sigma X, which is this kind of circle with a little nose there, that Greek letter sigma, lowercase sigma. So when you are dealing with these one variable statistics, what you need to understand is that every single time one of these numbers is great and one of these numbers is no good. So if you know you've got a sample, the first number is your standard deviation and the second number should be ignored. And if you know you have a population of data, then your first number should be ignored and your second number is the standard deviation. Other things you can get out of this are sample size, like n equals 29. That tells me there were 29 numbers in that data set in case I didn't know. The other things I get here, I get min, Q1, median, Q3, maximum. We call this the 5-number summary. This gives me the smallest X value, the median of the lower half of the data, which is called the 25th percentile or quartile 1, the median itself, which is the 50th percentile, and quartile 3, which is the third quartile, also called the 75th percentile, and it is basically the median of the upper half of the data. Also maximum, the largest value of X that we have. The final piece of data that you get from this is SSX, and it's literally every X minus the mean squared and added up together. This is another valuable piece of information for many statistical formulas, especially calculating standard deviation. So from this data, what you can get are a couple of things. The first thing you can get is the interquartile range. So interquartile range, which is a measure of spread around the median, we get by taking Q3 minus Q1. So we can pick the Q3 and Q1 numbers right out of the calculator, subtract those, and get our interquartile range. Another kind of calculation we can make is something called variance. Variance is what you get when you square the standard deviation. Okay, so if your standard deviation is 0.221 and you're asked to find the variance, all you need to do is take that standard deviation number and square it. So 0.221 squared is 0.049. That would be my variance. One thing that we find useful sometimes is being able to compare the mean and the median. So this will give us a real quick calculation of both of those to compare. I noticed that the mean is 5.448 and that the median is 5.46. Both of those are very, very close to each other. So I might say that the mean is approximately equal to the median, or that the median is slightly larger than the mean. So I can get those calculations. And then the other thing, again, is the 5-number summary. The 5-number summary are the numbers that we're going to need to calculate a box plot. When you calculate a box plot and you make one on hand, you are going to need to know the minimum value, the first quartile, the median, the third quartile, the maximum, and you're also going to want to know the interquartile range when you go to make those box plots. All right, so that is your 5-number summary calculation.